Good morning everybody. I am Mohinder Kumar, Senior Lecturer in Civil Engineering from Government Polytechnic College Bathinda. Today I will discuss with you on the very important topic of contouring from the subject of surveying to of 4th semester civil engineering. So, let us start with contour. So, an imaginary line on the surface, on the ground surface joining the points of equal elevation is known as contour or a contour line. So, you can call it a contour or a contour line. So, it is an imaginary line on the ground surface which joins all the points who have got equal elevations, that is all these points on this imaginary line have got equal reduced levels. So, once again I repeat, an imaginary line on the ground surface joining the points of equal elevation is known as a contour or a contour line. In other words, contour is a line in which the ground surface is intersected by a level surface obtained by joining points of equal elevation or reduced level. This line on the map represents a contour and which is called as a contour line. So, you have understood the meaning of contour or a contour line, or in the simple way we can call it, this is an imaginary line which has got every point of equal reduced level or elevation. So, now we come to contour map. So, you know what is difference between a map or a plan. So, we will study contour map. A map showing contour lines on it is known as contour map. So, a contour map gives an idea of altitudes. Altitude means reduced levels or levels of the surface features. So, a contour map gives an idea of altitudes of the surface features such as ponds, hills, valleys, etc., as well as their position, relative positions in plan, which serves the purpose of both plan and a section. So, a contour map generally serves the purpose of both a plan as well as a section. So, now we come to contouring. So, you all know the process of tracing contour lines. Tracing means we plot contour lines on the surface of earth is called as contouring. The process of tracing contour lines on the surface of the earth is called as contouring. You will understand in after the few slides how we do it. First, we conduct survey in the field, obtained levels in the field, then we plot it on the sheet itself, and then we interpolate, which means we plot the contour lines through these levels, and this process is called as contouring. That means the process of tracing number of contour lines on the surface of earth is called as contouring, and this process is done generally after doing survey in the field work and then plotting these field work data onto the sheets and then tracing the contour lines on the sheets. This process is called as contouring. So, what are the purposes of doing contouring? Contour survey is carried out at the starting of any engineering project such as a road, a railway, a canal, a dam, a building, or any other engineering project. Just at the start we carry out a contour survey. So, first point is for preparing contour maps in order to select the most economical or suitable site. That is, we have got number of options and we select the most economical or suitable site from it. Second is to locate the alignment of a canal so that it should follow a ridge line. So, you will understand what is a ridge line. So, idea behind selecting the ridge line is that the water should not stand on the road. So, we generally select the alignment which which should follow a ridge line only. Number 3 is to mark the alignment of roads and railways so that the quantity of earthwork both in cutting and filling should be minimum, that the quantity of earthwork should be minimum. Such alignment should be there in which the quantity of earthwork either in cutting or in filling should be minimum. Fourth one is for getting information about the ground, whether it is a flat, undulating, semi-hilly area or hilly area, or it is a mountainous. So, generally to get an idea about the ground surface, we conduct contouring. To find the capacity of a reservoir, that is how much quantity of water it can store, and volume of earthwork, how much quantity of earthwork is evolved, especially in a mountainous region. That is, generally in a hilly area, we generally have to know what will be the capacity of the reservoir in which water is to be stored, or how much quantity of earthwork is involved, whether in cutting or in filling. So, for doing such things, we generally do contouring. Next is to trace out the given grade of a particular route, that is on a hillside. If we are to select an alignment of road, we will have number of options and we can select the best suited alignment by doing contouring. Seventh is to locate the physical features of the ground such as pond, depression, hill, steep or small slope. So, to find out physical feature of the ground, we generally do contouring, that is whether there is a depression, whether there is a hill, steep slope is there, uniform slope is there or small slope is there. To find out all these things, we generally do contouring. So, there is again a very important definition. What is contour interval? The constant vertical distance, please note it, contour interval is constant. The constant vertical distance between two consecutive contours, that is one after the other contour, is called as consecutive. The constant vertical distance between two consecutive contours is called as contour interval. So, contour interval is constant. So, next is very important, again very important definition, horizontal equivalent. As its name suggests, the horizontal distance between any two adjacent, the contour interval was constant consecutive interval, but horizontal equivalent is between two adjacent contours, it is called as horizontal equivalent. So, once again I repeat, the horizontal distance between any two adjacent contours is called as horizontal equivalent. The contour interval is constant. This is very important. You just have listen both the definitions. The contour interval is constant between the consecutive contours, while the horizontal equivalent is variable, that it can change and it depends upon the slope of the ground. So, horizontal equivalent will be more if the slope is flat, and if it is steep slope is there, the horizontal equivalent will be less. So, horizontal equivalent depends upon the slope of the hill, whereas the contour interval will remain the same. So, once again I repeat, the contour interval is constant while the horizontal equivalent depends upon the slope. So, once again it is very important question from the examination point of view. What are the factors on which contour interval depends? You just have listened the definition of a contour interval. This is a constant vertical distance between any two consecutive contours, and following are the factors on which contour interval generally depends. So, first one is nature of the ground. In flat and uniformly sloping country, the contour interval is small. That is, if slope is less, contour interval can be small, but in broken and mountainous region, that is in a semi-hilly area, the contour interval should be large, otherwise the contours will be come too close to each other. Second is the purpose and extent of the survey. Contour interval is small if the area to be surveyed is small and the maps are required to be used for design work or for determining the quantities of earthwork, etc. So, contour interval will be small, while wider interval shall have to be kept for large areas and comparatively less important works. That is, if more accuracy is required, the contour interval will be small, and for less accurate works, the contour interval can be wider or more contour interval can be kept. Third is the scale of the map. The contour interval should be in the inverse ratio to the scale of the map. That is, the smaller the scale, the greater is the contour interval, and vice versa. Fourth one is time and expense of field and office work. The smaller the interval, the greater is the amount of field work and plotting work. That is, if we keep the small contour interval, we will have a great amount of field and plotting work. So, what are the common values of the contour interval? The following are the common values of contour intervals adopted for various purposes. For large scale maps of flat country, for building sites, for detailed design works, and for calculation of quantities of earthwork, it is generally 0.2 meter to 0.5 meter. So, for reservoir and town planning schemes, it is from 0.5 meter to 2 meters, and for location surveys, it is from 2 meters to 3 meters. For small scale maps of broken country and general topographic work, we can have contour interval as 3 meters, 5 meters, 10 meters or 25 meters. So, now we come again to a very important question. What are the characteristics of contours? That is, what are the properties the contour lines possess? So, very first is all the points in a contour lines have a same elevation. That is, if we have a contour line, all the points on this line will have the same reduced level. This is very important property of contour. That is, all the points in a contour line have the same reduced level. Flat ground is indicated where the contours are widely separated, and steep slope where they run close together. That is, if the contour lines are widely separated, it will indicate a flat ground, and if they are running close together, it will indicate steep slope. A uniform slope is indicated when the contour lines are uniformly spaced, and a plane surface when they are straight, parallel and equally spaced. Again, important characteristics: a series of closed contour lines on the map represent a hill. A hill will be indicated if the higher values are inside the uh, loop. You see on your monitor screen, as it is indicated, we have got 18 meter contours in the center. Higher values are inside, so it is indicating the hill, and the lower values are outside. So such type of contours will represent a hill. A series of closed contours lines on the map indicate a depression. That is, it will indicate a depression if lower values are inside. That is, if higher values are inside, it will indicate a hill. If lower values are inside, it will indicate a depression. Contour lines cross ridge or a valley line at right angles. As it is shown on your monitor screen, if the higher values are inside the bend, as it is being shown, 100 meter is inside the bend, so it indicates a ridge line. If the higher values are inside the band, it indicates a ridge line. And similarly, if higher values are outside the band, as is being shown on your monitor screen, 100 is outside the band, so it is indicating a valley line. Contour cannot end anywhere but close on themselves either within or outside the limits of the map. This is a very important characteristics of the contour. When you will be drawing contour lines, you will see that if a contour is starting in the has been started from the drawing sheet, it cannot end in between the figure. Either it will close on itself or it will come out of the drawing sheet or border of the drawing sheet. So this is an very important characteristic of the contour. Once again I repeat, contours cannot end anywhere but close on themselves either within or outside the limits of the map, which means outside the boundary of the map or a plan which we are drawing. So contour will either close itself in the limits of the boundary of the drawing sheet or it will come out. So this is very important characteristics of the contour. Another is contour lines cannot merge or cross one another on map except in the case of overhanging cliff. Please see on your monitor screen, as it is being shown on the diagram. We generally come across when we go to an hilly area, such type of hill is there which is projected from the top. So this which is called as overhanging cliff, and in such a case, if we draw the contour lines of such an hill after surveying, so contour lines cannot merge or cross one another on map except in the case of overhanging cliff. So it will merge or cross only in the case of overhanging cliff, as is being shown on your monitor screen. So another case is contour lines never run into one another. That is, they never meet one another except in the case of a vertical cliff. You will also find such an hill when you go to in a hilly area. So this type of hill is called as vertical cliff, as is being shown on your monitor screen. In this case, several contours will coincide and horizontal equivalent, as is being shown on your monitor screen, horizontal equivalent becomes 0. That is, all the contour lines they meet and the horizontal equivalent becomes 0. So such a cliff is called as, such an hill is called as vertical cliff. So contour lines never run into one another except in the case of a vertical cliff. In this case, several contours coincide and horizontal equivalent becomes 0. So, please see on your monitor screen, this is the characteristics of a vertical cliff. So, next is depressions between summits is called a saddle. As we have seen a seat of a bicycle, this is just like that. So, depressions between summits is called a saddle. It is represented by 4 sets of contours as shown on your monitor screen. It represents a dip in a ridge or the junction of 2 ridges, and in the case of a mountain range, it takes the form of a pass. So, line passing through the saddles and summits gives watershed line. So, depression between summits, it is called as saddle, and contours of saddle are being shown on your monitor screen. So, now we come to the methods of contouring. So, we have got mainly 2 methods of locating contours. First is direct method and second is indirect method. So, let us discuss first direct method. In this method, the contours to be located are directly traced out in the field. That is, they are traced out in the field directly by locating and marking a number of points on each contour physically. That is, we mark and locate every point on a contour line physically. These points are then surveyed and plotted on plan and the contours drawn through them. So, this is a example of direct method. So, once again I repeat, in this method the contours to be located are directly traced out in the field of locating and marking a number of points on each contours. These points are then surveyed and plotted on plan and the contours drawn through them. So, this direct method is most accurate, although it is most accurate, but very slow and tedious. Tedious means it is very difficult, as a lot of time is wasted in searching points of equal reduced level for a contour. That is, most of the time is wasted, much time is wasted in searching such type of contours of equal elevation. So, this work is quite tedious and time wasting. So, this is suitable for small area. That is why it is suitable for small area and areas where great accuracy is required. That is, if a great accurate work is required, only then and then we go for this direct method. So, how we do it? So, procedure is, I just explained. To start with, a temporary benchmark is established, for which you have studied in the last semester in the chapter of leveling near the area. So, we establish a temporary benchmark in the area to be surveyed with the reference to a permanent benchmark by fly leveling. You must be knowing fly leveling. So, that is the leveling in which we generally do foreside and backside only, no interside is there, that is called as fly leveling. So, we generally establish a temporary benchmark near the area to be surveyed with reference to a permanent benchmark by fly leveling. The level is then set up in such a position so that the maximum number of points can be commanded from the instrument station. So, points should be such that number of points will be maximum, which can be covered from over the this point. The height of instrument is determined by taking a backside on the benchmark established and adding to it to the RL of the benchmark. The staff reading required to fix points on the various contours is found out by subtracting the reduced level of each of the contours from the height of the instrument. So, we have just an example. If the height of instrument as we have as the procedure was explained. So, if the height of instrument is 82.48 meters, then the staff readings required to locate 82 meters, 81 meter and 80 meter contours respectively are 0.48 meters, 1.48 meters and 2.48 meters respectively. So, these are the readings which are required for the contours of 82, 81 and 80 meters respectively. The staff is held on an approximate position of the point and then moved up and down. That is, staff is moved up and down the slope until the desired reading which we have calculated. Just if the desired readings is obtained, then the point is marked with the peg. So, in this way we find out the points which shows the required readings. So, similarly various other points are marked on each contour. So, for 80 meter contours, 81 meter contour, 82 meter contours, we find number of such points by lowering or moving up or down the staff. The line joining all these points give the required contour. It may be noted that one contour is located at a time. So, this is very important. One contour is located at a time. Having fixed the contours with the range of the instrument, the level is shifted and then set up in a new position. The new height of instrument and the required staff readings are then calculated in a similar manner and the process repeated till all the contours are located. So, this process is repeated till all the contours are located. The positions of the contours points are located suitably either simultaneously with leveling or afterwards. That is, we can locate these contours either simultaneously with a level or we can locate it afterwards also. A theodolite, that is which is an instrument for finding out the angles, a compass you have studied, a plane table you have also studied. Traversing is usually adopted for locating these points. So, these are the instruments which we use for locating these contours, a theodolite, a compass or a plane table. Traversing is usually adopted for locating these points. The points are then plotted on the plan and the contours drawn by joining the corresponding points by dotted curved lines. That is, after that we draw these contour lines. So, this is the procedure of drawing contours by direct method. So, there is another method of direct method by radial lines method, as is being shown on the monitor screen, radial lines method of contouring. So, this method is suitable for small areas where a single point in the center of the hill can command the whole area. Radial lines are laid out from the common center by theodolite or compass and their positions are fixed up by horizontal angles and bearings. Temporary benchmarks are first established at the center of the hill and near the ends of the radial lines. The contour points are then located and marked on these lines and their positions are determined by measuring their distances along the radial lines. They are then plotted on plan and the contours drawn by joining all the corresponding points with the help of a plane table instruments. So, in this way we conduct this radial line method by direct method of contouring. Now we come to indirect method of contouring. So in this method, the points located and surveyed are not necessarily on the contour lines, but the